Question 5. A student set up the circuit shown in the diagram. There we go. You have a diode, a variable resistor, a cell, a switch, a voltmeter, and an ammeter. Okay. So the symbol for diode is that there, and the variable resistor is that there. You must put the arrow head in for a variable resistor. If you don't draw the line in the middle here, it doesn't make a difference. Okay, and that's 1 mark each. Now the circuit that you see has 2 mistakes in it. So this circuit here has 2 mistakes in it. What are they? The voltmeter is not connected in the right place, and the ammeter is not connected in the right place. The ammeter is always connected in series where the voltmeter is, and the voltmeter should be connected around the appliance, so around the appliance in this position. So these two need to be swapped around. So a voltmeter is always connected around the appliance, and the ammeter always in series. So here we are. So we write down voltmeter should be connected in parallel around a diode, and the ammeter should be connected in series in this scenario where the voltmeter is currently connected. So after correcting the circuit, the student obtained a set of data plotted in the graph below. So what potential difference, what voltage did the diode start to conduct electrical current? So we see that when we had voltages of 0 to 0.2 around the diode, nothing happened. No current was produced. Suddenly, after 0.2 volts around the diode, it lets current go through. So what potential difference does it start? 0.2. Some of you might have written 0.21 volts. Use the data from the graph to calculate the resistance of the diode when the potential difference across the diode is 0.3 volts. So this graph has current and voltage, or current and potential difference. And what we need is the resistance. So what formula connects them? Resistance equals voltage divided by current. So the voltage is given in the question is 0.3. So where do we get the current from? We have to go to the graph. So 0.3 volts is there. We go up and across and we find the current. Now we got to figure out what that value is, because it's not 0.01, that's slightly above. It's got 1, 2, 3, 4, 5 squares. So 0.010 needs to be divided by 5. That's 0.002. So that's 0.02, 0.004, 0.006, 0.008. A lot of students wrote 0.08 where you make the mistake. So your answer is 37.5, not 3.75 ohms. 1 mark for the answer, 1 mark for doing the potential difference, the voltage over the current, and then this has to be 0.008. So if you got this wrong and you got an answer of 3.75, you get 2 marks. Question 6. So you've got a current voltage characteristic graph drawn here of a filament bulb. This is of a filament bulb. A diode, this would be a diode, that one. Okay, so it's not diode. So if you go back into your notes, and thermistor is not that either. Right, 2 resistors, X and Y, are connected in parallel. To tell you in the question it's a parallel circuit. So straight away I know that's 6 volts. So I'm 6 volts across all the components. That's one of the rules for a parallel circuit. Current leaving the battery is 3 amps. It gets to this point here. 2 amps splits off. Then that means that 1 amp goes in this direction, because 3 amps comes in. If 2 goes that way, that means there's 1 left, so 1 must have come down this route here. That current then joins up to 3 amps and goes back to the circuit. So I've written these on the circuit. Maybe that will become of use. So what is the potential difference across X? So what's the voltage across X? Well, I've written it down already, 6 volts. So write down 6 volts. Calculate the resistance of X, where resistance is voltage divided by current. The voltage is 6 volts. The current is 2 amps. So 6 divided by 2, 3 ohms. So what is the current in Y? We have wrote that down already. That's 1 amp. Calculate the resistance. So that's voltage divided by current. So voltage divided by current, that was 6 divided by 1, 6 ohms. So it's final question. When the temperature of the resistor increases, its resistance increases. So what's happening here for X? When the temperature of this increases, the resistance of this increases. That means less current can pass through here. That means less current, because this still is 1 amp, because that resistance has not changed. We haven't mentioned that in the question. So that means this current has dropped. The voltage will stay the same, because the rules of parallel circuits, if that's battery voltage is 6 volts, every component will have the same resistance in parallel, same voltage in parallel. So it doesn't matter what the resistances are here, it will stay at 6 volts. But if this resistance does increase, that current will drop. And if this current drops, this plus this gives us this current here, this current will also drop, which is why the potential difference across X stays the same, the current drops, and the overall current in the circuit, which was this one here, will drop because this has decreased. Question 7. We have a circuit, but unfortunately it's not drawn the way we normally draw circuit diagrams, but they have outlined all the components. You do not need to draw the fuel tank. It's not required. When you draw a circuit diagram, we draw the components for electrical circuit. So we have got the battery, 12 volts. Don't need to write the 12, but the battery is there, the cell, the current, the ammeter in series, and it is connected as one big loop, and there's your variable resistor in series, and that gives you 3 marks. 1, 2, 3. How will the current in the circuit change if the level of the petrol tank decreases, or the amount of petrol here drops? That means this lever moves downwards and ends up maybe in this position here. That means that more wire, the current has to go through longer wire. And the more current, the longer the wire, the bigger the resistance on the variable resistor. So the fuel tank, the level of the fuel, petrol, will determine the resistance on the variable resistor. And because this lever will go further down, it will be touching a wire down here. So that means a current going from there to that point will have to travel a further distance. So the resistance would have dropped. And there we go. We have, as the petrol level falls, the resistance in the variable resistor increases. That means that the current in the circuit falls. And as a result, this will read a lower current.